So that last example was pretty heavy on the algebraic representation of functions and then the verbal as well because we were doing a word problem. This next one is going to be almost entirely, or probably entirely, graphical. As usual, we want to get a nice mix of all the different ways to represent functions. So for each little f, we're asked to sketch two antiderivatives big F, one with capital F of 0 being 1 and the other with capital F of 0 being negative 1. So we did some stuff similar to this back in week 4. In week 4, our main emphasis was sketching f prime when we were given f. But if you look back, we did a few examples where we started with the graph down here, which we called little f prime, and we tried to go backwards to little f. But at that time, we didn't have these words, like we didn't have a word antiderivative, so we couldn't talk about that. At that time, we also had constructed this useful chart, so let's remember how that worked. Back then, this was called little f, and this was called little f prime, but I hope you'll agree that I could call this capital F and call this capital F prime. And capital F prime is the same as little f. If capital F is an antiderivative of little f, that's simply what it means, that the derivative of capital F is little f. So let's fill in this chart. We said back then that if the graph of the original function is positive, the graph of a function is positive, we have no idea what its slope is. We have no idea what its slope is if the graph is negative, right? Knowing that capital F is positive or negative just tells you capital F is above or below the x-axis. Doesn't tell you anything about whether the slope of capital F is positive or negative. On the other hand, if capital F is an increasing function, what does that tell us about the slope of capital F? That tells us it's got to be a positive slope. And if capital F is decreasing, that means the slope of capital F, meaning capital F prime, is negative. And then these next two were actually just the way we defined the words. We defined the word f being concave up as f prime being increasing, and f was concave down when f prime was decreasing. So we might find it handy, you might find it handy, to look back at this chart while we're sketching our antiderivatives here. So let's start with this pretty simple one. This is supposed to be a horizontal line. Remember, this little f is the same as capital F prime. That is to say, it is equal to the slope of capital F. So what do we know here? We know the slope of capital F is negative, and slope doesn't change. So maybe this is saying it down here at negative 2. That says the slope of capital F is always negative 2. So what kind of graph does capital F have to be if its slope is always negative 2? I hope you are picturing a line, a linear function, with a negative slope. So I know I've got to have one of them go through f of 0 equals 1. So if I start up here like this, and I draw a line with a negative constant slope, and then I can label that 1, and I've drawn one of my antiderivatives. And as we know, any two antiderivatives differ only by a constant. So once you've drawn one of these, you get the other one pretty much for free just by shifting it up or down. And in this case, we want to shift it down how many units? We want to go from the point 0, 1, shift down to 0, negative 1, so we shift down 2 units. So I'm just going to try to draw something perfectly parallel, but that has a negative y-intercept instead of a positive y-intercept. So there we've got two antiderivatives of this little f. Let's move on to this one, which is maybe a little bit more interesting. You might remember that when we did these back in week 3, we tried to identify the places down here where something important happened. So that is to say, where the derivative, capital F prime, changed sign or changed between increasing and decreasing. So take a minute on your own right now maybe to try to figure out how many such places there are. Maybe even pause the recording. Try to sketch the graph on your own. I see only one place where that happens, right? So little f is positive and decreasing, and then little f is positive and increasing. So right here, something interesting is going to happen. So let's try to do this with the chart here. Remember, again, that little f is big F prime. So what two things do we know about big F prime from here to here? Two things that we actually care about. We know big F prime is positive because big F prime is above the axis, and big F prime is decreasing. So if you go back here, you pick that big F prime was positive and decreasing. So what does that tell us about the graph of big F that we're trying to draw? It says big F is increasing and concave down. That's the hardest of the four possibilities for people to draw, as we've mentioned before. So what does increasing concave down look like? That's the one that looks like this. So I want to draw a function. I don't know where to start. Just start somewhere. I draw a function that's increasing and concave down until I get to this point. So like that. And should the slope of big F be horizontal the way that I've drawn it there? It should, right? Because big F prime is exactly 0. Big F is on the x-axis right here. Now, what two things do we know about here? Big F prime is positive and increasing. So if we go back to here, big F prime was positive and increasing. So what's the change going to be? Big F is still increasing, but big F is now concave up. So we can draw something like that. And then we can label that point as 1. Of course, if you ever are told to try to draw, maybe we were just trying to get one of these, maybe just f of 0 equals -1, and I had drawn this, how would I get the right one? I could just shift this graph down and then erase the first graph that I drew. But here, if we want to get the second one, we just shift down 2 units. And do something like that and call that -1. And it's important to make this point here, where the slope is 0 on big F, line up down here, where big F prime is equal to 0. Take a look at this one. How many places do you think we have something important happening? I count 3 places. Right here, big F prime changes from increasing to decreasing. So something's going to be happening there. But here, big F prime changes from decreasing to increasing. And here, big F prime changes from negative to positive. So those are the 3 places where something interesting is going to happen. Remember, again, this is the slope of big F. Let's try to draw this without using the chart as much. This down here is a graph, as we've said, of the slope of big F. So what do we know about the slope of big F? The slope of big F is negative, but getting less negative. So what does it mean if your slope is negative, but getting less negative? What does your graph look like? Slope negative, but getting less negative means decreasing, but concave up. So if I start up here, the reason I'm going to start high is because big F is decreasing almost all the way, because big F prime is negative, and I know I've got to hit a positive y value. So I'm going to start off up here. And we are decreasing and concave up is what we said. Should the slope of big F here be 0? What do you think? I hope you're saying no, because here big F prime is below the x-axis. So maybe this is, say, big F prime is equal to -2. That means the slope here is -2. Unlike back here, where the slope really was 0, because big F prime did equal 0. So now what happens here? Big F prime is negative and getting more negative. So a slope that's negative and getting more negative is concave down. So now we're concave down from there to there. And again, it's important to make sure that your slope is not 0 right there. What do we know here? Big F prime is negative but getting less negative. That means the slope of big F is negative but getting less negative. So looking something like that. And then finally, for the first time, big F prime becomes positive. Meaning for the first time I'm about to draw a positive slope, big F prime is positive and getting more positive. So a slope that's positive and getting more positive is increasing concave up. We can call that point there 1. And of course, if you prefer to do this using the chart, go ahead. Should get the same looking graph. So if I'd like to shift this down, and just to remind ourselves of this, do these points where big F crosses the x-axis, this point here, this point here, this point here, these 2 points, do they have any relevance? If you have them different, is your graph still okay? Sure, because we don't know anything about big F being positive or negative just from big F prime. All that we know is the shape of big F. So if I shift this down, I think we'll go something like this. I'm going to go down into the graph down below here. That's okay. And then we label that point -1. So as always, these are supposed to be vertical shifts of each other. And this slope is not 0 here, just as that slope was not 0 here. Okay, let's do one more. So this one has got some of these sharp corners. And we saw that when we were taking derivatives, if we tried to take the derivative of a graph that looked like this, at a corner like this or at a corner like this, then the derivative would not exist at that point. Let's see what happens when we do the antiderivative, when we're trying to go the other way. So we've got a place here where something interesting happens, a place here, And let's look at what happens there too. So let's say we're going to go back to our chart for a second. From here to here, what two things do we know about big F prime that matter? Big F prime is negative and increasing. So if big F prime is negative and big F prime is increasing, we know these two things are true about big F. Decreasing, concave up. So I want to draw something that's decreasing and concave up there. Big F prime continues to increase, but big F prime is now positive. So if big F prime is positive and increasing, big F is increasing, concave up. And then what happens here? Should I put one of those open dots there to show that this big F doesn't exist there? What do you think? We talked about this back in week 4 as well. If big F didn't exist at a point, what would that mean about the derivative of big F? The derivative would definitely not exist. So if big F didn't exist, this graph down here would also have an open dot there. However, there is no open dot here. Since this graph is defined everywhere, big F prime always exists. So if big F prime exists, or if big F prime is defined, the graph of big F must be, we haven't used this word a lot, but we did define it way back then, must be differentiable, meaning that big F can't have any holes, can't have any sharp corners, nothing funny like that. And since big F prime here does always exist, that means my big F graph must always be differentiable, meaning there's nothing unusual really happening at this point except that we're going to get an inflection point, because now big F prime is going to start to decrease, meaning my graph up here is going to become concave down. So this graph has to be differentiable. It's got to be a nice, smooth transition there. You cannot have any sharp break there. If you did have some sharp break there, like if you abruptly change the slope, and the reason that I'm emphasizing this is because I see people do it on the homework and the exam all the time. If you abruptly change the slope here, then your big F is not differentiable, which means that this graph would have a hole in it, but this graph didn't have a hole in it. So we know we can't have any abrupt change in slope up there. And then what's true the rest of the way here? Big F prime is constant and positive, so we're just staying at a constant positive slope straight across there. And I guess we're going to have to call this positive 1 since that's where we cross the axis up there. And again, notice that this transition here was also very smooth, nothing abrupt happening there. And then we draw one more. And you'll just have to believe me that this is 1 unit above and this is 1 unit below the axis, that those are the same. We have an applet for you to experiment with these sorts of things by playing around with the graphs. You can manipulate the graph down here and change the graph up there. And then we'll move on to our next topic.